Isaac Newton was born on a small farm on Christmas Day in 1642. Newton was known throughout history as a mathematician, physicist, and astronomer, and became a key figure in the scientific revolution. In 1687, he published his most renowned work, Mathematical Principles of Natural Philosophy, which marked the epoch of a great revolution in physics. To formulate his physical theories, Newton developed and used mathematical models, which are now used in binomial theorem and calculus. Thus, infinitesimal calculus was born. Newton's work has been said to distinctly advance every branch of mathematics then studied, and has continued to be an important aspect of modern mathematics.
Newton's most famous and important contribution to mathematics are those of differential and integral calculus relating to the first fundamental theorem of calculus, which he is credited with discovering. He did so while attempting to find a method of calculating the slope of a curve at any given point. He achieved this by calculating a derivative function, which he called the method of fluxions. He also found differentiation had an inverse function, which he called the method of fluids. This allowed for the area under the curve to be calculated. Connecting these two concepts of calculus together, Newton created the first fundamental theorem of calculus. Newton is also credited with other mathematical discoveries. For example, Newton's method for root estimation is an application of differential calculus that remains one of the best ways to approximate a function's roots. Newton is also credited with the discovery of the generalized binomial theorem, which describes the expansion of binomial powers.
How did Newton impact other mathematicians? Well, Newton's work was, and still is, extremely influential in science and mathematics. He held many high-ranking positions, such as President of the Royal Society, which helped his influence to grow. Newton's development of differential and integral calculus revolutionized the way mathematicians of the time analyzed curves. However, another mathematician, Leibniz, also began using calculus at the same time as Newton, and a feud broke out between them, with many other mathematicians taking sides. Newton was, however, eventually accredited with its discovery. Newton also used his calculus and the work of other mathematicians such as Kepler to make many contributions to the field of mechanics, such as his famous 3 laws of motion. Newton was always in contact with other mathematicians such as Hooke and Haley, which allowed them to brainstorm together and make new discoveries.
Newton's primary strand of mathematics, infinitesimal calculus, involves differential calculus, integral calculus, Newton's method to approximate roots, and his generalized binomial theorem. Isaac Newton's scientific research greatly influenced his mathematical profession, influencing modern mathematics today as we continue to apply his work to everyday activities including education. Infinitesimal calculus has allowed mathematicians and engineers to understand the motion and the dynamic changes in the changing world around us. Newton's work on calculus has revolutionized how we calculate the orbits of planets, the motion of fluids, and predict the rate of change of functions and the area that they control. He calculated the derivative function, which in turn calculates the slope at any point on the function. This is called differential calculus. Some of his early calculations are as followed. Isaac Newton is also credited with inventing integral calculus. It is the opposite of differentiation and involves calculating the area underneath a curve.